Analysis 2016 questions on food labels. They start reasonably straightforward, but they do get harder. First thing though is I would take your calculator and make sure you've got it in statistics mode. So we're going to do mode 3. We want normal distribution type questions, so we're going to go to 1 and then I'll just clear that. Okay, so that's now ready to use. So first question. What is the minimum accepted volume for a 160 milliliter carton of juice? So if you look at 160 milliliters, it's in here. So basically it means we're allowed 4.5% either way. So 4.5% of our 160 is what we're allowed as our margin. So I do 4.5, I multiply it by the 160, divide by 100 because it's a percentage, and so it means I'm allowed 7.2 milliliters either way. So the minimum accepted volume means I do 160, take away the 7.2, and that comes to 152.8 milliliters. Question 2. Explain why the standard deviation of a 330 milliliter bottle should not be more than 3.3. So it's allowed to be less, but not more than 3.3 milliliters. The first thing to notice is that the 330 milliliter bottles form a normal distribution. So if it's a normal distribution, we also need to compare that with the accepted margin. Now, 330 milliliters in here, we're allowed 3% either way. So the first thing is find 3% of your 330 milliliters. That is the allowable margin. And 3% of that is 3 times 330 divided by 100 equals 9.9. So I am allowed 9.9 milliliters either way. Now if it's a normal distribution, it forms this sort of curve with the mean at 330, and I'm allowed to go at most 9.9 either way. I can go less than 9.9, but the furthest I can go to be within my accepted margin is 9.9 milliliters each way. However, a normal distribution, you're allowed 3 standard deviations from the mean. So the most we can do is if we had 3 standard deviations as equal to our 9.9, and that would mean for each standard deviation, if 3 standard deviations, if the most they could be was 9.9, so they're less than or equal to 9.9, each one must be less than or equal to 3.3 milliliters. Question 3. A 330 ml bottle has a mean of 330 and a standard deviation of 2.8. To 3 significant figures, what is the probability that one of these contains less than 325 milliliters? Well, again, it's a normal distribution. We want less than 325, so we're to the left of this, and there's my mean. So I want the probability that my value is less than 325. First thing, standardize it. So I change my x to a z, but the important thing is for standardizing. It's the value, 325. Take away the mean and then divide by your standard deviation. So on my calculator, I'm going to type in, I'm going to do the first bit in brackets, open brackets, 325, take away my mean, close my brackets, and then I'm going to divide by 2.8. So I want my z value to be less than this, minus 1.786 about, minus 1.786. So my z is less than minus 1.786. And then I need to say, well, what is p of minus 1.786? So I do shift 1, 5 for distribution, and I want less than, which is p. If it was more than, I'd use r. Less than, I'm going to use a p, which is 1. Now I could type in minus 1.786, but notice my exact answer there. That's a lot more exact for minus 1.786. So I'm just going to do p answer equals, and I get 0.037. Okay, and I want 3 significant figures, so it should be 0.0371. I don't know if I put 0.0371. Yes, I did. Okay, so that is the probability of being less than 325. Now, if I want to do it for more than 325, I could do the same process again, but instead of doing the P, press the R. But there's a quick way. These two values here, that area and that area, in a normal distribution, they add up to 1. So the probability of being less than 325 is this. The probability of being more than 325 is 1 take away 0.0371, and that comes to 0.963. So all I had to do was subtract this from 1. If it hadn't been 325, if it had been a different number there, I'd have had to do a full calculation. Part C I'll do on the next page. I want to be between 326 and 332. So there's my mean. I want to be between these two, so this shaded area here. And the way to think of it is I want probability 326 less than x less than 332, so I'm in between it, is if I look at this shaded area, I want to be to the left of a 332, that gives me all of that, and then if I take away to the left of a 326, I'm left with a shaded area. So I want the probability of being less than 332, less than the bigger number, take away the probability of being less than 326. So it's that area, take away that area, leaves me with a shaded area. Now I standardize as normal. So the first one, it's 332, take away my mean, divide by the standard deviation. The second one, 326, take away the mean, divide by the standard deviation. So I've got to work those out and what they come to. I'm going to do this one first. So I do 332, take away the mean, and divide it by the 2.8 equals 0.7143. Let's see if that's right, 0.7143. Now I'm actually going to work out what P of that is straight away while I've got that number on my calculator. So I'm going to do shift 1 and 5 for distribution, 1 for P, and I want P of answer as I did before. So I'm doing P of that number there equals 0.76247. There it is. Now I do the same thing here. So I go back to the start and I do open brackets, but this time it's 326 minus 330, close the brackets, divide by 2.8 equals, so that's minus 1.4286. Let's see what I've got. Minus 1.429, I've rounded it to there. But it doesn't matter if I've rounded it, because I'm now going to do P of that. So I do shift 1, 5, 1 again for P, and I'm doing P again of answer. So I don't have to type the thing in, otherwise I could make a mistake typing it in. Equals, and that's coming to 0.076564. Subtract those two numbers and I get 0.686. I'm not going to bother doing that subtraction. You can do it yourself, and rounded it to 3 significant figures. Question 4. 4% of the bottles in the above question are found to be leaking because they are too full. What is the minimum volume of a bottle which leaks? And it's 1 decimal place my answer. So the top 4% are leaking because they're too full. Now I don't know what the value is this time. This time it's the other way around. I need to find that value, so I call it A. So my probability that x is less than A, well, I could do probability x is more than A as 4%, or probability less than A is 96%, because they're going to add up to 100%. So I can either do probability x less than A, 0.96, or probability x more than A is 4%, which is 0.04. It doesn't matter which of these I do. I prefer to do to the left, but it doesn't matter which. So now I standardize. It's value A minus the mean over the standard deviation. And here, value minus the mean over the standard deviation. See, you're getting exactly the same thing. The difference is here it's less than for my 0.96. Here it's more than for my 0.04. Right, now what I need to do is I need to find, well, what value is going to give me that 0.96 or 0.04. So if I go to this and I do shift 1, 5, 5, 1, my P, if I'm doing P, otherwise I can do it with R, I can now guess some numbers to see if I get 0.96. So if I just guess 2, let's say, that comes to 0.97. That's a little bit too much. So maybe I should try, oh, I shouldn't have done that. Sorry, shift 1, 5, 1. I tried 2, let's try 1.9, 0.97. Again, still a bit too much. So let's go back, change it to 1.8. 0.96, you see I'm gradually starting to get closer, and I will gradually try to home in. And what I find is that I should gradually get to 1.751. If I have there, when I get 1.751, that's pretty near to the 0.96. Now if I did it this way, I'd do exactly the same process. I'd do shift 1 and home in from 5, but this time, because I'm going to the right of it, it's to the right of it, the 4%, I would use the R, and this time I'll be doing R of 2. Okay, that doesn't work very well, so I'll be looking for R's of different numbers. Now, what I'm going to find for my R is I want to get 0.04. You see that's nowhere near it, but if I try using that number there, let's try 1.7. Oh, I've done the same thing again. Shift 1, 5, R, sorry, let's try R of 1.7, so it's near to that. You see, I'm now trying to get to 0.04 rather than 0.96, so I'm not that far away. And if I do that same value, you see, again, it's very, very near to that 0.04. So it doesn't matter which way I do, I prefer this one, but whichever way I do it, I'm going to get that value 1.751 is working. And now I've got an equation to solve. So I've got to solve a minus 130 over 2.8 equals 1.751. Incidentally, some of you will have found how to get the 1.751 from tables, from working backwards from tables instead of using the calculator. So here, a minus 330 is divided by 2.8 is that. The opposite of divided by 2.8 is multiply by it. So I multiply it by 2.8. That comes to that, and then I add on the 330, and I'm getting 334.9 about. So to one decimal place, it's 334.9 millilitres is my answer. Question 5. For the bottle in mentioned question 3, it's the same bottle again, 330 ml one. What's the median? What's the interquartile range to two significant figures? Right. Well, the thing is this. If you have a normal distribution, the first thing to realize is that the mean is in the middle and the median is also in the middle. So in a normal distribution, because of the symmetry, the median and the mean are the same as each other. So if the mean is 330, the median is 330. So that's nice and easy. Just remember, in a normal distribution, the median and the mean are the same. Now we need to work out our interquartile range. Now you're used to doing this from a cumulative frequency curve, and obviously we haven't got that here. But the key thing with quartiles is it's dividing the data into quarters. Now we could do that with our normal distribution. I'm dividing the area into quarters. So there's the smallest quarter of the area under the graph, there's the next quarter, there's the next, and there's the next one. And quarter obviously is the same as 25%. So if I want my upper quartile and my lower quartile, one of them, the lower quartile, is below A, and that's got to come to 25% or 0.25, and below B has got to be 75%. So probability for X is below A is 0.25. The probability it is below B will be 0.75. And I could instead have done above B as 0.25. Now if I solve those, it's the same method as I used before. I standardize first. A minus the 330 divided by the 2.8 in each case. Here it's b minus 330 over 2.8. Then I go to my calculator and I've got to get 0.25 or 0.75. I'm going to do shift 1, 5, 1 for p, and I want to get 0.25, okay? So, in effect, over here, I'm going to be trying some minus numbers. What if I try minus 1? Okay. What if I try minus 0.8? Is that better? No, that's worse. What if I try minus 1.5? Oh, sorry, I've done the same thing again. Shift 1, 5. I keep doing this. 1, p of minus 1.5. Okay, that's actually got worse. So I want to do minus 0.8. Let's try that. Okay, that's not too bad, is it? And so I'm gradually going to try homing in here, and I actually get minus 0.6745. So if I eventually tried there, I could have tried minus 0.7. You see it's gradually getting nearer, and then if I go back to there, and when I try minus 6.745 equals 0.25. So that's the one I want. Now the interesting thing is, because of a symmetry over here, to get plus 0.75, all I need to do is get rid of that minus sign. If I do that, you see I get 0.75. So I've got these two equations to solve. So firstly, a minus 330 over 2.8 equals this. Secondly, b minus 330 over 2.8 equals that. You could use shift solve if you wanted to, but this gives you a equals 328.1. There, a equals 331.9. So our interquartile range, this is the upper quartile, that's the lower quartile. Subtract 1 from the other, and you get 3.8 as our interquartile range. So the method there was split them up into 25%, standardize, and then find what value of p we needed to end up with 0.25. It came to that. What value when we put p in came to 0.75, it was that, and then solve our equations. Right, question 6. A 2.5 litre bottle is normally distributed with a mean of 2.5 litres. It is found that 10% of bottles contain less than 2480 millilitres. Find the standard deviation of these bottles to 3 significant figures and then see if they're in accepted margin. Let's do the standard deviation bit first. So, 10%, 2480. So 10% of them are below 2480, and 2.5 litres of course is 2,500 millilitres. There's my mean. So P, and I'm using Y now just because it's a different bottle. I could use X. It's less than 2480, and I'm told that's 10%, which is 0.1. So it's the same process as before, standardize. But this time, I know the value, I know the mean, I don't know the standard deviation. Previously, I knew the standard deviation. So here I get 2480 minus 2,500 over that is there. Now, I can do that subtraction. 2480 minus 2,500 is minus 20. So I know that this value here, pz less than minus 20 over the standard deviation, is 0.1. So I want to be finding what gives me 0.1. Back to the calculator, you see it's well over to the left, so it's going to be a minus value. So let's do p there. Let's actually keep what we had before, delete it through, let's do minus 2. That's 0.02, I want minus 0.1. What happens if I do minus 1? That's better, it's in between those two. So I'm going to go now for minus 1.2. Okay, that's getting better. Okay, And what if I do minus 1.23? Do you see it's getting better still? Let's try minus 1.27. Okay, and minus 1.28. That is pretty near to what I want there. Okay, what minus is equal to 0.110027. So I'm basically going to home in. It's the same sort of idea as I've done before. So I've got that this is about minus 1.28. I could go more accurately if I wanted to. So minus 20 divided by the standard deviation is minus 1.28, multiplied by my standard deviation, minus 20 equals minus 1.28 times it. And now do the minus 20 divided by the minus 1.28, and that gives me 15.6. So what I did is I did minus 20 divided, let's cancel that, minus 20 divided by minus 1.28 equals 15.6. Okay, I didn't actually need the minuses in there because they cancel each other out. Okay, now let's have a look at whether that is acceptable. So we've got a standard deviation of 15.6. So are they within the accepted value? Right, it's 2.5 litres, which is 2,500 millilitres. So we're allowed to go 1.5% each way. So the accepted margin is 1.5% of my 2,500 millilitres, and that is 37.5 millilitres. Let's check that. 1.5 multiplied by 2,500 divided by 100 equals 37.5 millilitres. Okay, so we're allowed to go 37.5 millilitres each way. Now, at first glance, you might say, well, 15.6 is less than that, so that's okay. However, you are meant to be able to go 3 standard deviations below, so my data could be within 3 standard deviations. I will have some bottles at the very end, here and here, which are 3 standard deviations away from that. So there'll be 3 lots of 15.6 away. Well, 3 standard deviations is about 47 millilitres. So I will have some bottles which are 47 millilitres away, but I'm only allowed to go 37.5 millilitres away. Therefore, a few bottles will be beyond the accepted margin. So the answer to that, are they within the accepted margin? The answer is no. Some of the bottles, maybe only a few, but a few of them won't be within the accepted margin. Okay, that's quite a hard one to finish with. Good luck in the exam.